profit maximization problem we solved the last class. Before we look at the slides, okay. Basically, what we did to solve the profit maximization problem is first we solve a cost minimization problem, right? Then we get the minimal cost function, which is a variable cost function. Then we set up a profit maximization. In the second stage, we just have one variable, y. We just choose what is optimal y, given we know what is the minimal cost. Okay. So put them together, we have two steps. Okay. We divide the profit maximization into cost minimization, then find the output. Stage 1, we minimize R1, X1 plus R2, X2. We choose X1 and X2, subject to the production function Y. Is f of X1. The first order condition of this problem, this minimization problem is the first order condition. Remember lambda f1, the partial with respect to is R1, and lambda f2 is R2. And also we have this constraint f of x1, x2 is equal to y. So we have three equations, three unknowns. We can solve all of the three unknowns, lambda, x1, x2, right? So what we did was, solve the cost minimization problem. We first eliminate lambda from the three equations, which gives us this f1 over f2 is r1 over r2, and f1 over f2 is RTS, rate of technical substitution, right? So that's one condition, okay? Well, this is the equation, and we then combine this equation with this equation. We have two equations, two unknowns, so we can solve for x1 is d1 y r1 r2, x2 is d2 y r1 r2. What are the names of these two functions? Do you remember?
The demand.
Demand. What demand for what? For factor. Factor demand. Demand function. And also we call this conditional factor demand because we're conditional on the y level, output level. So it's conditional factor demand. With that demand functions, if we substitute x1, x2 back into the cost equation, we also get this cost function. Okay, which is the variable cost. Okay, so that's stage 1. What do we got here? We got a behavior equations. Okay, this factor demand tell you when price changes or the output target changes, the optimal choice of the producer in terms of how much input they use is going to change. Okay. So these two equations tell you that. And then in stage 2, okay, we're trying to maximize total revenue minus total variable cost. Okay, that's profit. So with that, we can write this as Py minus this function. Variable cost we already got here. It's minimized, the minimum cost. C of y, R1, R2. Okay? So now P is taken as given because we assume the firm is taking all prices as given. So we have just one choice variable, y, the output level, y. Okay? So the first order condition is E minus marginal cost is equal to 0. So the marginal cost, maybe I should, P is equal to the part, what is marginal cost? Marginal cost is the partial of this cost function with respect to y. But look at here, this is one equation with one unknown, y. So we can solve that equation to get the y, the output level. Okay. Once y is determined, okay, we can substitute this y back here to get the optimal inputs when y is relaxed. So this first gives you the y function. Okay. Now this y P minus partial cost is equal to 0. Okay. And this C function, C depends on y, R1, R2. Okay. So that gives us the y, the product supply function, output supply, which depends on P, of course, and R1, R2. This is output supply. Well, this is not finished yet because when you determine y, you also can determine x1, x2 because y depends on this function, the other three variables. So you can substitute y back into x1, x2 to get this. x1 is equal to, I'm going to call this little d. Now this little d depends on P, R1, R2. Because y disappeared, y is replaced with this function. Okay. Everybody follows me? Yeah. x2, p2, okay. So this is the output supply. These are the fact demands. Now I eliminated the term conditional, because we don't have to conditional on the output. Okay, so this fact demand is different from conditional fact demand. Okay, conditional fact demand depends on the output level. Okay, but fact demands do not depend on output level. It's always profit maximizing. So it depends on all the prices. So basically, we completely solve for the optimal solution for this problem, maximize profit. Okay, this is one approach we have taken, but there's an alternative. Okay, the alternative is here. I will just start from directly maximize my profit. Okay, but I write my profit as P times f, y is f of x1, x2, minus r1, x1, minus r2, x2.